All right, we're going to continue our work with linear equations, linear functions. Specifically, in this video, we'll be looking at parallel and perpendicular lines. And we're going to start off with an introduction and then a couple solved examples. So a reminder of what parallel lines are. Parallel lines never intersect, and parallel lines have the same slope. Okay. More specifically, particularly in geometry, parallel lines need to lie in the same plane as well. You can imagine two lines that lie in different planes but don't intersect. Those are called skew lines, by the way. Okay, so see if you can imagine that. Two lines that are not parallel but also do not intersect, right? So we're working with all in the same plane, which makes sense in algebra because we're working on the xy axis system in the Cartesian coordinate plane. Perpendicular lines intersect at right angles, and the slopes, importantly, are negative reciprocals of each other. So if the slope for one of them is 5/3, the slope of its perpendicular is -3/5. So you flip the fraction and you make the new slope the negative of what the other slope was. Let's do a couple examples. So the two examples we'll be doing are one, writing an equation for a parallel line, and then next, writing an equation for a perpendicular line. So first example, let's write an equation for a line parallel to the given line 3x plus 2y equals 7 that goes through the point -1, 4. Okay, so we have an initial line and a separate point that we want our line to go through. So real quick rough sketch that is not going to plot the actual given points that I'm given, but let's say we have this line and this point. Okay, we want to find the equation of this line that is parallel to the given line, that's the symbol for parallel, and goes through the point we're given. All right, let's do it. So I want to find the slope first. The only thing I care about for our given line is the slope. Nothing else matters. All I care about is its slope. So I'm going to do that by getting it into mx plus b form. Subtract 3x from both sides. Oops. Did I do that right? -3x plus 7, yep, equals 2y. And let's divide by 2. So again, all I care about is that, -3/2. Okay, so now we have a point and a slope. And we're going to put those two pieces of information together and come up with a line. Now, it didn't say what form we want our line to be in, so I'm going to go the most efficient route and just put it in point-slope form. If it doesn't specify, I think you get to choose. I think that's fair. But if it does specify, you really want to make sure that you follow what your teacher's asking. So let's do it. So reminder of point-slope form, y minus y1 equals m times x minus x1. Being careful with those negatives, right? So we have a y minus our 4. Here's the 4 we're working with. Equals our slope, -3/2, times x minus our x value, which is -1. And let's deal with that double negative. Y minus 4 equals -3/2 times x plus 1. All right, so we got it. So we have a new line that has the same slope as our original line, but goes through the given point. Next one, we're going to be writing an equation for a perpendicular line. Okay, and so the rough sketch of what this might look like, again, I'm not going to be showing the exact points or lines that we'll be working with. I'm just trying to model the situation. We have a given line and we have a given point that's off the line somewhere, and we're looking for the equation of this line that is, if I could draw a perpendicular line, that would be helpful. Let's try to see if that looks better. That looks better. So it goes through this point and it is perpendicular to the given line. So we're looking for the equation for the red line in this example. All right, so we actually have a little bit of an easier situation here because we already have the slope of our given line. I'm going to write that slope as a fraction, negative 5/2. So that's our original slope. So our new slope is the negative of that with an inverted fraction, so a positive 2/5. Okay, and just like in the prior video, it doesn't specify what form we're going for, but I'm actually going to go for slope-intercept form just to remind you of that. So we have a point and a slope now, okay? And we just need to get all that into slope-intercept form. So let's write out slope-intercept form. And let's plug in the information we have. We have a negative 3 as our y-coordinate, m is 2/5, our x-coordinate is 4, and we're curious, what's b going to end up being? So we need to multiply our fraction by 4, so that's 8/5 plus b, and then we can subtract 8/5 from both sides. And let's see where we get here. We have a negative, let's get a common denominator. So we have a negative 15/5. That's what negative 3 is. This negative 3 turns into negative 15/5 minus an 8/5 equals b. So b is a negative 23/5. So we can write out our information that we figured out into our slope-intercept form equation. And we're going to get y equals 2/5 x minus 23/5. And that would be our final equation right there. And that would be a good place to stop.